Namaste, students. I'm Dr. Amita Kapoor, and welcome. Today, we're going to do something a little different. We're not just going to learn about data, we're actually going to become data detectives. Yep, our mission is to look at a bunch of numbers and figure out the hidden story inside. So, maybe grab a mental magnifying glass and let's start our investigation. So, let's start with a really basic question. When you think of a detective, what's the first thing that comes to your mind? What's their main job? Exactly, right? They don't just guess. A good detective observes everything really carefully. They collect all the clues, fingerprints, bits of evidence, and from all those little pieces, they start to see the hidden pattern. They figure out the story of what really happened. Well, a data detective does pretty much the exact same thing. It's just that our clues are numbers. Now, you might be thinking that this whole data detective thing sounds very modern, something that only happens with computers. But the truth is, the spirit of being a data detective is actually deeply, deeply rooted in our own history. It's a long and very respected tradition. That's right. I mean, long before anyone had a laptop or even dreamed of a spreadsheet, our very own ancient rishis and scholars were mastering these exact skills. Their tools were definitely not digital, but their minds, incredibly sharp and analytical. And this is where we can really connect to our amazing heritage. Our ancestors actually had specific names for these detective skills. They followed the principle of pariksha, which just means systematic, super careful observation. They weren't just glancing at the sky, they were recording what they saw day after day. And from that data, they used anumana, which means logical inference, to draw conclusions. A fantastic example of this is the Bruhat Samhita from the 6th century. In it, scholars meticulously recorded patterns and clouds, winds, and stars, all to understand and even predict the weather. This table just shows that connection perfectly, doesn't it? The tools have totally changed, for sure. Instead of writing on palm leaf manuscripts, we use things like Python and data frames. Instead of just patient observation, we now have organized data sets. And the beautiful art of Anumana, well, today it's powered by the science of statistics. But the core mission, finding the truth hidden in patterns, that has stayed exactly the same. Okay, so feeling inspired by our ancestors, let's take on our own modern investigation. We have a case file right here in front of us, a little mystery hidden inside some simple weather data. Here it is. This is our evidence. 10 days of observations, just like the scholars of the past might have recorded. We've got temperature, humidity, and air pressure. Now, at first glance, it just looks like a list of numbers, right? But we know better. We know there's a story hiding in there somewhere. Now, to work with this data on a computer, we put it into something called a data frame. Don't let that technical name worry you at all. A data frame is, quite literally, just a digital version of the table we were just looking at. It's just a way to organize our clues so our modern tool, the computer, can help us investigate. So, our mission is clear. We're going to take this data, these modern observations, and we're going to apply the same principles of inquiry that our ancestors used. We are going to find the hidden patterns. All right, every good detective needs a toolkit, and they know exactly where to start looking for clues. For us, the very first step is to figure out what a typical day even looks like in our data. And for that, we've got some really powerful statistical clues. Just think about it. Trying to keep all 10 of those temperature readings in your head at once is kind of overwhelming. So, how can we boil all of that information down into just a couple of simple, powerful numbers that tell us the main story? Well, here are our first three major clues. You probably know the mean. That's just the average. You add them all up and divide. The median is the number that's sitting right in the middle after you line them all up in order. And the mode, that's simply the number that shows up most often. Each one gives us a slightly different idea of what's typical. And here are the results for our temperature data. The mean, or average temperature, was 24.4 degrees. The median, or middle value, was 24. And the most common temperature, the mode, was 22. See how close the mean and median are? That's actually a clue itself. It tells us our data is pretty balanced. And this is the crucial part. With just three numbers, we've basically summarized 10 days of data. We went from a long, confusing list to a powerful, insightful snapshot. That's the first big step in solving our mystery. Okay, so we've got our numerical clues. Now it's time to use another incredibly powerful detective tool, our eyes. We're going to visualize the evidence to see the story in a completely new way. Numbers are fantastic, they really are, but sometimes they can actually hide the bigger picture. A really good chart or graph, well, it can make patterns just jump right out at you in a way that a table of numbers just can't. Take a look at this. This is a histogram. It's a really cool way of showing how our humidity data is spread out. Each bar represents a range of humidity, and the height of the bar tells us how many days had humidity in that range. You can see right away that the tallest bar is over on the left. That's a huge visual clue. But wait, we're not done. A truly skilled detective knows that you can't just look at the evidence from one angle and call it a day. What do you think happens if we change our perspective? Just a little bit. And this shows it perfectly. On the left, that's our original histogram. Think of each bar or bin as a big bucket we're sorting our data into. There, we use 5 big buckets. But on the right, we use 10 smaller buckets. And look what happens. This more detailed view shows us something new. We can now see 2 separate peaks that were totally hidden before. Just by changing our perspective, we uncovered a deeper pattern. Okay, we've collected our clues, we've calculated our statistics, and we've visualized the evidence. Now it's time for the final, most important step, bringing it all together and solving the case. So here's the method we followed, a process that any data detective can use. 1. Get your data, your case file. 2. Find those key statistical clues, like mean, median, and mode. 3. Visualize the scene to really see the patterns. And 4. The final step, state your findings. Tell the story of what the data is showing you. And as you do this, I really want you to remember this one thing. This isn't just some modern computer exercise. When you analyze data, you are taking part in a noble ancient tradition of pariksha and anumana, of observation and inference. It's a tradition that connects you directly to the great scholars and thinkers of our past. You've done it. You've successfully cracked this case and found the patterns in our weather data. And you know what? You can apply these exact skills to almost anything: sports scores, music, your exam results. So, my final question to you is this. Now that you're a data detective, what mystery will you solve next?